Hey guys, so sorry that I can't be with you today. However, I am going to go through this video. That way you're still getting your instruction. We're going to start by reviewing a little bit of what we learned the other day. Alright, now the first thing that we talked about was the area of a parallelogram. And before we can go into that, y'all have to understand what a parallelogram is. A parallelogram is a four-sided figure, also called a quadrilateral, with two pairs of parallel opposite sides. In other words, when we have our parallelogram, imagine that I'm Pablo Picasso and that, is accurate. Our opposite sides are parallel, and these little feathers or arrows, whatever you want to call them, signify what sides are parallel. Okay, so top, bottom are parallel, left and right sides are parallel. The formula to find the area of a parallelogram is simply base times height. So area is equal to base times height. Keep in mind, though, that a parallelogram is not just this shifted rectangle here. A parallelogram is also a square, and it's also a rectangle. Okay, so, and I gave this analogy to my 8A classes, and I kind of wish I thought about it with you guys. But think of parallelogram as kind of like a broad topic. Like if I were to just say car, okay, there are infinite, or not infinite, but there's many different brands of cars out there, right? You have Toyota, you have Honda, you have Nissan, Ford, list goes on and on. And then within those different brands, you have different types of cars. Like Nissan has the Maxima, the Altima, the Sentra. Honda has Accord, Civic. Ford has, I don't know, but hopefully you get the general idea here. So parallelogram is the broad topic. And the types of parallelograms are this type here. This shifted rectangle, what have you, square, and rectangle. Okay. Moving on. The second one that we talked about was a triangle, which is a three-sided figure with three angles. All right, there's two different ways that I can write the formula to find the area of a triangle. And I'm going to give them to you both. They mean the same thing, so use whichever you're more comfortable with. The way I learned it is 1/2 times base times height. The way that y'all are used to seeing it represented is base times height divided by 2. Again, if you're more comfortable with this one, use this one. If you're more comfortable with the second one, use that. Whichever way you need to do to work the problem. The third figure that we talked about was a trapezoid. All right, now a trapezoid is a quadrilateral. It's a four-sided figure. However, a quadrilateral differs from a parallelogram in that it's a quadrilateral with only one set of parallel sides. So let's let that, oh, boom. Okay. So let's kind of somewhat try to draw a quadrilateral. Y'all know I'm not exactly an expert here, but a trapezoid is going to look like this, okay? And it only has one pair of parallel sides. All right, with this side here and this side, at some point they're going to touch. So that leaves this one and this one to be parallel. And this is what we refer to as our bases. So this, for example, could be base 1 and this would be base 2. The height, is same with all of these, is how tall that figure actually is. This is what we would call the slant height. There's a big difference, and we'll go into that more next week, but this would be the height. The formula to find the area of a trapezoid is 1/2 times the height times base 1 plus base 2. Now, y'all did pretty well with this the other day, but we are going to work another example just to make sure that it's refreshed and on the top of your mind. You'll need it for the activity that I have planned for you today. So here we have a map of the United States. This is California, and this here is Nevada. And we're using this one because Nevada is kind of sort of shaped like a trapezoid. So the first thing that you need to do in order to find the area of Nevada, remember this is an approximation because, obviously it's not an exact trapezoid, but, approximately. Thought this was a fun little example. But 1/2 times height times base 1 plus base 2. So we need to first identify what the parts of the figure are. So look in here, and this is just my way of doing it. It seems easier to me to do it this way, but it might not be for you, and that's okay. I'm going to first identify what are my bases. Remember, your bases are your parallel sides. So this side and this side are parallel. That means that this is one base, so we'll call this base 1, and this is base 2. Now keep in mind, remember your height is the side that's perpendicular to your base. Remember, perpendicular means that it's crossing at a 90-degree angle. And we can tell if it's crossing at a 90-degree angle if and only if I either tell you that this is 90 degrees or it has that little box there. That little box does mean this angle is 90 degrees. So that means this is my height because it's perpendicular to that base. So let's plug in our values into our formula. We have 1/2 times our height, which is 320, times base 1, which is 207, plus base 2, which is 483. We work what's in our parentheses first. You have to remember to follow your order of operations, which is PEMDAS, P meaning parentheses. All right, so 1/2 times 320 times 690. 207 plus 483 is 690. Our next step is to distribute this 320. That gives us 1/2 times 220,800. So when we multiply this, we end up with 110,400. Now we're dealing with area, so I'd like for you to get in the habit of writing that A equals. And because we're dealing with the area, we have to have squared units. In this example, our units is miles. So we're going to have 110,400 square miles. And that is our approximate area for the state of Nevada. Remember, this is approximate because, it's not exactly a trapezoid. All right, let's go to the next example. It wouldn't be me if I didn't take it one step further. All right, so let me fill in our values here. This is going to be the height. Imagine that's correct, guys. Use your imagination. This is 5 meters. This is 4 meters. This is 10 meters. And this is 6 meters. So notice I am not giving you up front a very key piece of information that we need to find the area of this trapezoid. Okay, I've given you bases. This side is parallel to this side. So that means this is going to be base 1 and this is going to be base 2. But notice I didn't give you the height. But we have enough information here that we can solve it. So when I draw my dotted line that represents my height, it creates a right triangle out of this section of the trapezoid. And we know from our last unit that we can use our Pythagorean theorem to find the missing side. Pythagorean theorem, let's refresh here, says a squared plus b squared is equal to c squared. So before we can continue, we need to pick apart and determine what in this triangle is going to be A, B, and C. Remember, A and B refer to your legs, okay? And our legs are going to be this two right here. So we'll say that this is B, and C is your hypotenuse, which is opposite that right angle, so this is C. So when we throw that in here, we get A squared plus 6 squared is equal to 10 squared. We're solving for A, so I need to move this 6 squared to my other side, which leaves A squared is equal to 10 squared minus 6 squared. 10 squared is 100, and 6 squared is 36. 100 minus 36 is equal to 84. Now I'm solving for A, not A squared. So to get rid of that squared, I have to take the square root of both sides. That leaves A here. And the square root of 84, that's one of those perfect squares that we talked about. Because when I take the square root of 84, I get a whole number. So you can put this in your calculator. I hope that you remember off the top of your head what it is. But the square root of 64, not 84, guys, that's my bad. The square root of 64 is 8. So that means our height is 8 meters. So guys, if y'all did not understand how that worked, please rewind this video, go back, watch this section again. And if you still have questions about it, that's okay. Write it down on your paper somewhere. Write it down on a sticky note or something. Put it in the basket. I'll look over it when I get back on Monday. So that's okay. It's okay if we have questions. So now that we know our height, we finally have every piece of information that we need to find the area of this trapezoid. I'm just going to erase what I don't need here. Okay, so our formula, 1/2 times height times base 1 plus base 2. Our height is 8. Base 1 is 5. And here's where it kind of gets a little tricky. Base 2 is this whole section right here. We know that this part of it is 4 and this part is 6. So in order to find the length of that whole base, we have to add those two values, which means it's 10. Add what's in your parentheses first. So 1/2 times 8 times 15. Now we distribute our 8. 1/2 times 120. Half of 120 is 60. And because we're dealing with area, guys, we cannot forget our units. So 60 meters squared is the area of this trapezoid. Awesome. Let's move on. So today we're going to talk about a rhombus. Let me go back in here. There we go. Okay. So we're going to discuss a rhombus. And a rhombus is another type of quadrilateral, meaning it is a four-sided figure. It's also a type of parallelogram. And it's a type of parallelogram, and I'm gonna make that note here. It's a special type of parallelogram. And it's going to come up in text so y'all can understand it. Nice little cool feature I figured out today. Woohoo. All right, so we're going to talk about 4 special characteristics of a rhombus, okay? The first one is, of course, the opposite sides are parallel. So same rule as a typical parallelogram. The second one is that all sides are congruent. And quick refresh right here, congruent means that they're the same. The second point, or the third point, I'm sorry guys, third point, the diagonals are perpendicular. And I'm going to show you what this looks like in a second, but make sure that you get this written down. Diagonals are perpendicular. And then the fourth is that the diagonals bisect the angles. All right, so I'm going to give you a second to get this written down. So, rhombus has 4 special characteristics. The opposite sides are parallel, same rules as a parallelogram. All sides are congruent. Diagonals are perpendicular. And the diagonals bisect the angles. So, let's look at what that looks like real quick. So, a rhombus is going to be more of your diamond shape. All right, so whereas a parallelogram can be like a shifted rectangle, a rhombus, that special type of parallelogram, is going to be more of a shifted square. Okay, so you can also call it a diamond, but the geometrically correct name is rhombus. All right, so remember that first characteristic we talked about. Oh, no. That first characteristic we talked about, opposite sides are parallel, okay? So this side is going to be parallel with this one, and this side is parallel with this one. The second characteristic, all sides are congruent, meaning if this is 6, this is 6, this is 6, and this is 6. All right, the last 2 characteristics are what I want to show you on this second rhombus over here, where it talks about diagonals. And I know you've heard that term before. We used it when we were doing the Pythagorean theorem, but a diagonal is a line that goes from one angle to the next. Imagine that straight. Use your imagination. All right, so that's a diagonal, and that's a diagonal. That's awful, guys. I'm so sorry. All right, so the diagonals of a rhombus are perpendicular. So that means where these interact, or not interact, but where they intersect, it creates all right angles. Imagine this is drawn perfectly, okay? Second, or that last characteristic, was that the diagonals bisect the angles. Meaning that when I drew that first diagonal, and I may actually back it up and show you a little bit more here. So when I drew this first diagonal, what it did is it bisected both of these angles. It's drawn perfectly, remember. All right, now we haven't talked about bisect in quite a while. That was back from our very first unit. So I'm going to give you a quick little rundown here. If I'm talking about an angle bisector, which a diagonal is an angle bisector, it means it's cutting that angle into 2 congruent pieces. So if I tell you that this angle is 60 degrees, and I draw that diagonal there, guess what each of these individual pieces are? They are both 30 degrees, because 60 divided by 2 is 30. Make sense? Hopefully. I can't hear you. I don't know why I'm asking. All right, moving on. Here we're going to talk about a kite. And I'm going to throw in another slide here so we can go over those characteristics because a kite has its own special characteristics as well. Kite. So a kite is another quadrilateral, meaning it's a four-sided figure. It has two distinct pairs of adjacent sides. So that's the first main characteristic. It has two distinct pair of adjacent sides. It's not letting me redo that. Two distinct pair of adjacent sides. The second characteristic is that the diagonals are perpendicular. The diagonals are perpendicular. And the third one is that a kite has two pairs of opposite angles that are congruent. And I'm going to show you what this looks like on an actual kite here in just a second. Make sure you get these down though. A kite has two distinct pairs of adjacent sides. The diagonals are perpendicular, and it has two pairs of opposite angles that are congruent. So now let's look at what that looks like, okay? First characteristic is that they have two distinct pairs of adjacent sides that are congruent. That means that this side is congruent to its adjacent side, this one. Okay, obviously it's not congruent to this one. It's, they look way too different for that. All right, and then this side is congruent to its adjacent side, which is this one. So these two sides are congruent, these two sides are congruent. The second characteristic said, again, the diagonals, and I'm going to try to do this as straight as possible, the diagonals, just like with the rhombus, the diagonals are perpendicular. Means they cross at 90-degree angles. And then that third characteristic, and this is going to come in handy next week, so make sure you get this written down. The opposite angles are congruent. So these two angles are opposite, and they're congruent. These two angles are opposite, and they're congruent. Alrighty then. So now, let's look at the formula for finding the area of a kite in a rhombus. Now, the formula is the same for both. Okay? Area is equal to 1/2 times diagonal 1 times diagonal 2. So A stands for area, and D1 and D2 are the diagonals. So notice that all quadrilaterals have two diagonals, just two. Any four-sided figure are only going to have two diagonals. And remember, diagonals are lines drawn from one angle to its opposite angle. So here we have an example of a kite, and I know this is on your problem. Go in your this is on your notes. Go in your textbook to page 624. This value is 3. We're dealing with a kite, so if this is 3, that means this one is 3. This is 2, and this is 5. So the length of this diagonal is 6 meters altogether. The length of this diagonal is 7 meters altogether. So your formula is 1/2 times diagonal 1 times diagonal 2. So we have 1/2 times 6 times 7. 6 times 7 is 42, and half of 42 is 24. So the area of this kite is 21 meters squared. Example number 2. This is a rhombus, not a kite, a rhombus. So, oh, guys, I'm so sorry. So remember, in a rhombus, all sides are equal. That means that this side of the diagonal is going to be equal to this side. This side of this diagonal is equal to this side. So if I tell you that this is 6 feet, that means that this is 6 feet. If I tell you this is 2.5 feet, that means that this one is 2.5 feet. So altogether, this diagonal is 12 feet, and this diagonal is 5 feet. So when we plug this in to our formula, and I think I need to back it up real quick, but we're just going to keep working. Plug this into our formula. We have 1/2 times diagonal 1 times diagonal 2. No, guys, my bad. We definitely need to back it up. Pardon me. This will give me a chance to read all that diagonal too. Alright, so we have this one, not much better. We have this one. So this is 6.5 feet, and this is 2.5 feet. Now, because all sides are equal, that means this is 6.5 feet, this one is 6.5 feet, and this is 6.5 feet. But that also means that if this diagonal, or this section of the diagonal is 2.5 feet, that means this section is 2.5 feet. So this is another one of those problems where they don't give you exactly what you need in the problem. You have to kind of take it a step further before you can solve. So I need to figure out what this side is. Again, this is a right triangle. Remember that the diagonals intersect at a 90-degree angle. They're perpendicular. So I can use my Pythagorean theorem where this is C. So a squared plus 2.5 squared is equal to 6 squared. I need to isolate that a squared, so I subtract. A squared is equal to 6 squared. It's not going to let me do that. A squared is equal to 6 squared minus 2.5 squared. 6 squared is 36. 2.5 squared is 6.5 squared. I'm so sorry. So we have 2.5 squared, we'll call it b squared now, I've already written it, is equal to 6.5 squared. Subtract that 2.5 squared. B squared is equal to 6.5 squared minus 2.5 squared. 6.5 squared is 42.25. And 2.5 squared is 6.25. When I subtract these, I get 36. And I have to take the square root of both sides, which means that B has a value of 6. That means that this side is 6. But because we are dealing with a rhombus, and all sides are equal, which means that if this is a diagonal, this section is 6, then that means that this section is 6. So I hope you got all this. If not, pause the video now because I'm fixing to erase it. So that means that the length of this diagonal is 12 and the length of this diagonal is 5. So the area is 1/2 times diagonal 1 times diagonal 2. So we have 1/2 times 12 times 5. 12 times 5 is 60. So we have 1/2 times 60. And 1/2 of 60 is 30. And remember, guys, we're dealing with area, so our answer has to have those units squared. I hope I didn't confuse you too bad with that. But I did do it right this last time, so if you need to rewind it a little bit, work it again, please do so. That concludes this video for this lesson. If you need to rewatch it at any time for any reason, it is on Canvas. It will stay there. So now you need to do that maze activity. Excuse me. It is front and back. And it is due before you leave class. Remember, guys, the sub is going to leave me a note. You know what I expect from you, so please be respectful. Do what you need to do. Do what you're asked to do. Do what you're told to do. Have a wonderful day. You'll have another video from me on Friday. Remember, I'm not going to be there Friday either. If you have any questions, send me an email. If not, guys, good luck. I miss you, and I will see you next week. Thank you.